Alright, in this video here we are going to be talking about how to evaluate trigonometric functions of angles. Alright, so a lot of the things we talk about in this video are based on things that I've done other videos on. So if you haven't seen the video that I did on reference angles, which is the one I just did before this one, you might want to check that one out. If you haven't seen the videos that I did on the unit circle or the trig hand and the definitions of the trig functions in terms of the unit circle and the terminal points on the unit circle, we're going to be using all of those things in order to evaluate the trig functions of angles. So if there's any of those things I just mentioned that you're not familiar with or you forget, you might want to pause this one and go back and watch some of those other videos to review that stuff before you carry on with this one. This one is kind of assuming that you've already absorbed all that material and you understand it so that you can then use it to do this new stuff. Alright, so first thing we do when we want to find the sine of 345 degrees or cosine of 240 degrees or something like that. First thing is find the quadrant in which the angle theta lies. Alright, so we want to find the terminal side of that angle. In which quadrant is that terminal side going to be? Right, so we want to figure out the quadrant first. Number two, we're going to find our reference angle theta bar that's associated with the angle theta. Right, and again, I just did a video on how to do reference angles and how to find them. So if you haven't seen that, you might want to check that one out so you have an understanding of reference angles and what they mean. So we'll find the reference angle. The next thing we do is we use the unit circle or we use the trig hand. And again, if you haven't seen the video I did on trig hand, check it out because it's very helpful in helping you know the values that you should know from the unit circle. All right, so we use the unit circle or the trig hand to get the terminal point for our reference angle. And then we change the signs of that, if we have to match the quadrant of our angle theta. Right, so our reference angle is always going to be an angle from the first quadrant. Right, and we can use our trig hand to get the terminal points of the angles in the first quadrant. And then we just basically change the signs based on which quadrant we're in. So if I'm in the second quadrant, I make x negative and y positive. If I'm in the third quadrant, I make both x and y negative. If I'm in the fourth quadrant, I make x positive and y negative. All right, so that's what we're talking about here, changing the signs to match the quadrant. And then the last thing we do is we evaluate the trig function using the terminal point. Right, so that's knowing the definitions of the trig function. The sine function is the y coordinate of the terminal point. Right, the cosine function gives you the x coordinate. The tangent function is the y over the x, and so on. Right, so a lot of things that I've done videos on previously, the definitions of those trig functions in terms of the terminal points, the trig hand and the terminal point on the unit circle, reference angles, all those things are important in order to be able to do what we're doing here. All right, so what I'm going to do now is pause the recording and erase all these steps, and then we'll do as many examples as we have time for where we go through these steps and actually evaluate trig functions for different angles. And we'll do angles both in degrees and radians, just so you see it using both of the measures of angles that we have. Alright, so here we go. We got the first two examples, sine of 240 degrees and then cotangent of 495 degrees. Alright, so first off, 240 degrees. I need to identify in which quadrant that's going to lie in my coordinate plane. Alright, so remember, when we're doing angles, they're always in standard position, which means the initial side is on the positive x-axis, and 240 degrees, well, let's see. No, the positive y-axis will be 90 degrees, the negative x-axis is 180 degrees, right? That's half of a full revolution. The negative y-axis would be 270 degrees, and then we know a full circle would be 360 degrees. So where is 240 using those benchmarks? Well, 240 is between 180 and 270, right? And it's, which one is it closer to? It's closer to 270 degrees, all right? So here's my angle, 240 degrees, is the angle starting up here and rotating around this way, more than half of a full revolution, but not quite 3/4 of a full revolution, right? So there's my 240 degree angle. Alright, so I know that my angle is in quadrant 3. That's my first step. Where is this angle? Just where's that terminal side end up when I rotate 240 degrees? And when you're dealing with degrees, you can use the x and y axis as your guidepost. Hopefully those are easy for you to remember, that if this is 0, this is 90, this is 180, down is 270, and then all the way around is 360. And then just you're looking at your number, 240. Alright, which ones of those two numbers is this in between? Alright, that's basically all you're doing there to figure out which quadrant you're in. Not so hard when you're dealing with the degree measure. It's a little bit more difficult when you have to deal with radians, which we'll do an example of that in a few minutes. All right, so I know my 240 degrees is in the third quadrant. Next, I want to find the reference angle, right? Recall, the reference angle is the acute angle between my terminal side and the x-axis. So the reference angle is going to be this one in here, right? From my terminal side back up to the x-axis, right? So it's the angle between 180 degrees and 240 degrees. So to find that, I just do 240 minus 180, which equals 60, right? So my reference angle here, my theta bar, is 60 degrees. All right, so that's my reference angle. Remember, the reference angle is always in terms of the x-axis, never in terms of the y-axis, right? So you say, well, it's closer to the y-axis, so let me just say that that's 30 degrees and then my reference angle is 30. No, right? The reference angle is always going to the x-axis, right? So 240 degrees is 60 degrees away from the x-axis, so my theta bar equals 60, all right? 60 degrees. Okay, so there's my reference angle, and now what I'm going to do is use my trig hand, or my knowledge of the unit circle, for the first quadrant of the unit circle to figure out what is the terminal point for my reference angle, 60 degrees. Right. Well, 60 degrees, if I do my my first quadrant of the unit circle, or just my first quadrant in general, right? Here's 0 degrees, then it's 30, 45, and then 60, and then, as we said before, the positive y-axis is 90 degrees. So 60 degrees is that third angle that we have in the first quadrant, on our unit circle. And so that corresponds to my index finger, right? And once again, if you haven't seen the videos that I've done on the unit circle and on trig hand, you should probably check those out so you understand what I'm doing here, holding my hand in this weird fashion. But this gives me my terminal point, right? The numbers above is my x coordinate, so I have one finger above. So my terminal point, my x is 1/2. And then I have 3 fingers below. That's my y coordinate. Is going to be the square root of 3 over 2. Right? So my terminal point for 60 degrees in the first quadrant is 1/2 comma root 3 over 2. Right? That would be the terminal point on the unit circle for that angle of 60 degrees. Well, in my fourth quadrant, right, this 240 degree, sorry, in the third quadrant, when I have this 240 degree angle, since I'm in the third quadrant, I'm going to have the same numbers there, except in the third quadrant, all of my values are negative. So my terminal point for 240 degrees is going to be negative 1/2, negative root 3 over 2. Right, if you think about it, the 60 degree angle is going to be directly across the circle from the 240 degree angle. Right, it's just directly across over in the first quadrant. 240 is over here in the third quadrant. Right, so if I basically just reflect these values across the unit circle to the other side, which makes them both of them negative. All right, so that is my terminal point for 240 degrees. Now, sine of 240 degrees, well, the definition of sine is the y coordinate, which is root 3 over 2. So sine of 240 degrees is going to be negative square root of 3 over 2. All right, so that's how I can evaluate a trig function in degrees using the unit circle, using reference angles, using my trig hand for the first quadrant. And the more of these you do, the quicker it does become. This one took us quite a few minutes to do because I was kind of very slowly explaining what we're doing in each step. But if you get it, you're like, all right, 240, that's between 180 and 270. That's 60 degrees from 180. So let me go to my first quadrant. 60 degrees is this one. 1/2 root 3 over 2. Sine is the y, so it's root 3 over 2. But it's in the third quadrant, so I make it negative. And I just did all that work in like 20 seconds to get my answer. All right, so the more of these you practice and the more you get used to working with the unit circle and finding reference angles, you can take something that took us 5 minutes, and like I said, I just talked my way through it and did it in like 20 seconds. Right, so what I'm trying to say is practice this stuff. Do homework problems, do extra practice problems. The more you do, the quicker and easier it becomes, I promise. All right, the next one. Let's see if we can do this one a little bit quicker. All right, cotangent of 495 degrees. All right, so 495 degrees. Where is that in the unit circle? Well, 495 is bigger than 360. So let me do 495 minus 360, which gives me 135. All right, so 495 degrees is going to be coterminal with 135 degrees, right? They're going to end with the same terminal side. And 135 degrees is going to be in between 90 and 180. It's actually halfway between 90 and 180, right? There's my 135 degree angle, which is the same as 495. 495 is a full lap, and then another 135 from there. All right, so there's my angle for 495 degrees. It's in the second quadrant. All right, my reference angle, taking that down to the x-axis, if I do 180 minus 135, that's going to give me 45 degrees. So my reference angle here is going to be 45 degrees. So I go to my trig hand, the first quadrant. The 45 degree angle is the one in the middle of the first quadrant, root 2 over 2, root 2 over 2. All right, that is my terminal point for 45 degrees in the first quadrant using my trig hand. So if I'm in the second quadrant, I'm going to have those same numbers, except my x has to be negative. So negative root 2 over 2, root 2 over 2. There's my terminal point for 495 degrees, which is the same as 135 degrees. Those are coterminal. All right, and now I'm doing the cotangent of 495 degrees. So what's the definition of cotangent? Well, tangent is the y over the x, and cotangent is reciprocal of that, so cotangent is the x over the y. Right, so cotangent of 495 degrees is my x-coordinate, negative root 2 over 2, over the y-coordinate, root 2 over 2, and since I have the same thing over itself, they cancel out, and I have that negative still, so it's negative 1. Right, so cotangent of 495 degrees is going to equal negative 1. Right, so I did that one a lot quicker than I did that first one up there. And like I said, the more of these you practice, the more you do, the faster you can work your way through it. But just real quick reviewing, right, 495, that's bigger than 360, so I subtracted 360 to get the coterminal angle, which is 135. I know that 135 is between 90 and 180, which means it's in the second quadrant. I did 180 minus 135 to get that reference angle, which is 45 degrees. I used my trig hand. 45 is the one in the middle. Root 2 over 2, root 2 over 2. That's my terminal point in the first quadrant. If I reflect that over to the second quadrant, I have to make the x-coordinate negative. So it's negative root 2 over 2, root 2 over 2. Then I do the definition of the cotangent function, x over y, which when I put the x over the y and I simplify it, I get negative 1. That's the value of my cotangent of 495 degrees. All right, so that's doing a couple examples using the degree measure of the angle. I'm going to pause this here and put up probably just one example doing the radian measure of an angle. All right, last example we'll do here in this video, secant of negative pi over 4. All right, so first thing, in which quadrant am I going to find negative pi over 4? All right, so it's a negative angle, which means I'm starting on my positive x-axis, but I'm rotating in this direction. And pi over 4, well, if I go pi over 4, that's just halfway through that first quadrant. So if I do negative pi over 4, that's going to be halfway through my fourth quadrant. All right, so there's my angle of negative pi over 4. All right, so my angle here is my terminal side is in the fourth quadrant. Right now, my reference angle here from this terminal point back up to the x-axis would be pi over 4. Right, it's the same angle. It's just when I do my reference angle, it's always in terms of a positive angle. Right, so if I do now, if you want to do that in terms of actually like subtracting like we did before, all the way around the circle would be 2 pi. Well, let me do it like this. Like this would be 0 radians here, and that's negative pi over 4. So if I did 0 minus negative pi over 4, that equals positive pi over 4. That's my reference angle. Right, that's like what we did before, like the 180 minus 135, and that gave me the 45 degree reference angle. Same idea here. All right, so my reference angle is pi over 4, which is the one in the middle of the first quadrant. Pi over 4, that's my middle finger, root 2 over 2, root 2 over 2. Right, and if you're not understanding what I'm doing and how I know that pi over 4 is the one in the middle and to use my middle finger on this hand here, or what that hand even represents, go back and watch the videos that I did on the unit circle and the trig hand and the trig functions. And that's where I'm getting all this information from. At this point, I'm assuming you kind of already know all that stuff. All right, so there's my terminal point. If I'm in the fourth quadrant, I reflect that terminal point down, but I make the y-coordinate negative, right? Because in the fourth quadrant, the x's are positive, but the y's are negative. And then I do my definition of secant, right? So secant is 1 over my x-coordinate, right? Again, knowing those definitions. So it's 1 over root 2 over 2, which is the reciprocal of root 2 over 2, which is 2 over root 2, which if I rationalize that denominator, I get 2 root 2 over 2, which equals the square root of 2. All right, so secant of negative pi over 4 equals the square root of 2. I did that last simplifying thing real quick just because we're running out of time, but you can look at it and figure it out for yourself. You should be able to do that by now. That's evaluating.